In this video, we're going to talk about 2.6 Objective 3, where we find points of discontinuity or intervals of continuity. Let's determine the points on the interval 1, 5, which the function f has a discontinuity. At each point of discontinuity, state the conditions in the continuity checklist that are violated. So the three conditions are f of a is defined, and a is in the domain of f. Second is that the limit of f of x as x approaches a exists, and the third is that that limit that exists is equal to f of a. The value of f equals the limit of f at a. So f of x is going to be discontinuous at x equals to 2 because it violates the fact that 0.1 here, right? That f of a is not defined, f of 2 is not defined there. So this equals 2. Let's see, and it's also going to be discontinuous at x equals 3, and it's going to be discontinuous at x equals 4. We're not worried about the endpoints of 1 or 5. So at 2, it violates the first condition. At x equals 4, it violates the second condition. X equals 4 equals violates the second condition, and then x equals 3 violates the first and second condition, passes the first and second conditions, but violates the third condition. Okay, so again, at 2, there's no point there. At 4, there's a point, but the limit doesn't exist. At 3, there's a point and the limit exists, but they're not the same thing. All right, there's discontinuities at 2, 3, and 4 here. And then at 2 and 4, there's no function value, so it violates the first condition. Second condition, which says that the limit exists, is violated at 2 and 3. And there's no point that violates the third condition, where the limit exists and the function value exists, but they're not the same thing. All right. Determine the intervals of continuity for the function. So it's continuous on 0 to 1. Let's see, they want these separated by comma. Usually we would use a union symbol here, but it doesn't like union symbols in my lab, so we'll go ahead and do this 1 to 2. And then 2 to 3, and then 3 to 4. I think that's it. So it's piecewise continuous here, 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 and there. F is continuous from the left at x equals 3. That's this one, that it's going to equal the function value here as it comes from the left. None of them are continuous from the right. Right, determine the intervals of continuity here. So that's going to be 1 to 2, 2 to 3, 3 to 4, 4 to 6. Okay. And continuous from the left, nowhere. And continuous from the right at 3. What is the domain of this function? The domain is -5 included to 5 included. And f is continuous on its entire domain there. I don't agree with saying that it's continuous at its endpoints, because I can't say that the limit exists if it only comes from the from one side. Limits have to be two-sided. So I think that the answer should be this. Ask your teacher what the answer should be, but my labs gives the answer of this. There's a good argument to be made that there's no activity from the left here, so the limit can't exist at that point, and it can't be continuous at an endpoint anyways. Continuity is on an open interval. No, it's not. It's closed because you have to be, you have to have the limit equal the endpoint. So what they're talking about here is that this point is continuous from the right and this point is continuous from the left, because that's the only way that you can approach. But when we get to differentiability, we'll deal with that. Okay. Let's just leave that at what it is there for number 5 and move on. Discuss that more with your teacher if you have a question about that. Let's see, if we factor this 3x x and then +2 and +1, this is x times x plus 5. Nothing's going to cancel. As I approach -5 here, the function is going to be continuous because 5 is in the domain, and piecewise and rational functions are continuous on their entire domain. So oh, sorry, 5 is going to be undefined. -5. I thought it said 5. That's a -5. That's going to make it undefined because there's a vertical asymptote there. So that is C. When I stick 3 in here, it's not in the domain. So that's C. It's not defined there. If I stick 15 in here, let's make sure that the limit is the same from the left and the right. X plus 15. So no, it's not continuous because there's, although f of 15 is equal to 4 is defined, the limit of f of x as and the limit as x approaches 15 of f of x equals 30. They're not the same thing. That's B. (6x minus 1 over x minus 1 times x minus 6). So there's a vertical asymptote there. It's not defined. It's a polynomial, so it's continuous on negative infinity to infinity, its entire domain. This is determine the intervals on which the function is continuous. So negative infinity to -2, -2 to 2, 2 to infinity, and I'm just basing that off of the denominator. I don't really need to know about the numerator to decide continuity there. Same thing here for 12. It's negative infinity to -2, -2 to 2, 2 to infinity. This is going to be negative infinity to -8, -8 to 8, and 8 to infinity. This is going to be negative infinity to -3, -3 to 3, and 3 to infinity. Suppose the f of x is defined as shown below. Use the continuity checklist to see if it's continuous or not continuous at 3. So from the left, 9 plus 3 is 12. From the right, 6. So the limit exists, the function exists, but they're not the same thing. Limit from the left and the right don't agree. Go. 15 is A. It's not continuous. It's continuous from the right. Right here, greater than or equal to. So that limit is equal to that function value. Intervals of continuity are going to be negative infinity to 3, and then 3 to infinity. But it's discontinuous at 3. All right, same question here. As I stick a 0 in, I get 2. If I stick a 0 in here, I get 0. So the limit does not exist. It's continuous from the left. And my intervals are negative infinity to 0 and 0 to infinity. Okay, so they're saying because this was continuous from the right, I should put a closed bracket there. Because this was continuous from the left, I should put a closed bracket there. All right. Determine the intervals on which the function value is continuous, at which finite endpoints of the interval of continuity is f continuous from the left or continuous from the right. So we have 3x squared minus 81 needs to be greater than or equal to 0. X squared minus 27 needs to be greater than or equal to 0. And we have, this needs to be negative 27. 27 function does not exist in here. It does exist here and here. and so root 27 is 3 root 3. We're saying plus or minus here. So negative infinity to negative 3 root 3, and it's going to agree there that it's going to be 0. And then from 3 root 3 to infinity, like that. Where it's continuous from the left is negative 3 root 3, where it's continuous from the right is 3 root 3, right? This is continuous everywhere. B and B here, and this is continuous everywhere. So there's not going to be any endpoints to worry about. That's going to be continuous everywhere. This is going to be discontinuous when x equals -1 or 1. But I'm sorry, when x equals 1. So we've got, it's allowed to be, x has to be greater than or equal to 0. And x cannot be equal to 1. We've got 0 to 1, not included, and 1 to infinity, like that for my domain. And 2 more problems here. F of A is not defined there. Limit doesn't exist here because it's going to negative infinity on one side and positive infinity on the other side. The limit doesn't exist and the function doesn't exist. And no, the limit doesn't exist, the function doesn't exist, and they don't equal each other, right? So where is this continuous? This is going to be continuous for x squared minus 10 greater than or equal to 0. X minus root 10 plus root 10, x minus root 10 greater than or equal to 0. Negative root 10, root 10, and negative times a negative is a positive, which is good. This is a negative, which is bad. This is a positive, which is good. So I am from negative infinity to negative root 10 and root 10 to infinity. And it is left continuous at negative root 10 and right continuous at positive root 10. And that's it for this video. And we'll come back next time and talk about 2.6 Objective 4. See you for the next video.